Hello, everyone, and welcome to our webinar, Beginner's Guide to Vector Embeddings. My name is Matt Brown, and I'll be your moderator today. One of my main jobs at SingleStore is to organize weekly AI webinars, 2 per week, demoing data and AI use cases, new tools, and technologies. I post about these upcoming webinars every week, so if these topics are interesting to you, feel free to connect with me or follow us on SingleStore's social media accounts to stay in the loop. I'd also love to hear any feedback you have or ideas on topics for our future sessions. Speaking of future sessions, we've got a great one coming up next week. If you click to the next slide, you'll see that on Thursday, we are going to be presenting Claude 3 Cookbook, leveraging OCR and multimodal data extraction. So this will be a live demo on how to use Claude's latest release and how it can be used for OCR and image recognition of multiple data formats and file types. I've seen it myself already. It's very, very cool. Less of the old problems of trying to recognize a different design or formatting of a document. Claude 3 is getting very, very good at this. So hope to see you there. The short link is there on your screen. I'll put that in the chat in a minute, or you can take a photo or a screenshot of that QR code. And I hope to see you next week. Getting back to today's topic, you're welcome to participate in the discussion throughout the session using the Zoom Q&A button at the bottom of your console. We have an internal mission statement to answer 100% of audience questions. Please make sure that you include your name and email address, though. We will not be answering any anonymous questions. We would also love for you to try out the technology that we're going to be talking about today. So if you click to the next slide, you'll see that today we are offering a chance to win either new AirPods or Meta's new Ray-Ban LLM smart glasses. It'll be your choice if you're the winner. All you need to do to participate is visit this link that's on your screen. I'll put this in the chat as well. You just have to log in and try it out. If you've already got an account, that's great. Just log in and we'll register you. If you don't have an account, if this is your first time joining us, you can just visit that link and sign up. We not only have a free trial with $600 of credits that we've had for a while, but we also have a completely free shared tier. No payment obligations whatsoever. So feel free to check it out. Just visit that link and I will announce the raffle winner at the end of today's session. So let me introduce our speaker. Pavan is a developer evangelist at SingleStore. He is a Gen AI, DevOps, data science, and machine learning enthusiast. He's a self-taught developer and a prolific author. He is becoming a great mainstay at our SingleStore webinars. He's got a little following online. I encourage you to follow him. He's got great content on his blog and social media accounts. Pavan, great to see you. Welcome. The floor is yours.
Thanks, Matt. Thanks for that lovely introduction. Hey guys, welcome to this webinar on vector embeddings for beginners. So yeah, this is, first of all, my name is Pawan Belgatti, like Matt said. I'm a developer evangelist at SingleStore. So today, this is the table of contents. I'm going to talk about traditional databases, next emergence of specialized databases, like vector databases, embeddings, what is chunking, and how to create and store vector embeddings, the representation of these vector embeddings, and then at last, I'll also show you a demo on how to create these vector embeddings and then store them and then retrieve them using dot product, all this semantic search, right? So yeah, let's get started. So if you see database for a traditional application, for example, take your own banking application and you would like to see your bank balance. So you'll hit that button. The first thing when you open your application, the first thing you see is the user interface, what we call UI, and then the business logic kicks in to retrieve the data related to you. So you can see in this whole application lifecycle the importance of database in storing, managing, and retrieving data, right? So as we know that traditional databases are good in storing simple data like rows and columns data, which is very simple format. But what if you have a high dimensional unstructured data? That is where vector databases, the specialized databases that everybody is talking about, come into play. So this is how, in the form of vectors, you represent different words, sentences in a three-dimensional space in a vector database. So yeah, again, traditional database versus vector database. What is new in vector database? You need a vector embedding model where your data gets converted into vector embeddings that gets stored in a vector database. Whereas in traditional databases, storing of the objects data is very easy, right? It's in simple rows and columns format. So before getting into this vector embeddings, we should understand one more important factor, that is chunking, right? What if you have a large document? Uh, you need to chunk it, right? Chunking data for embeddings involves breaking down this large amount of, large pieces of data into smaller, more manageable pieces so that you get the right context, right, before creating these embeddings. So you can see in the image, large document is getting, getting cut into smaller pieces. Like that's what we call chunks. And you can see as if, right, before chunking, the whole data is in a big paragraph, right? After chunking, you can make them little smaller chunks, and then so that your LLM application can retrieve, through semantic search, more appropriate results. So yeah, you can see the whole life cycle, like load the documents, the data from external sources, then chunk those documents into smaller pieces, chunk one, chunk two, chunk three, what you see, n number of chunks, and then all these chunks are given a numerical value. That's what we call embeddings. Embedding one, embedding two, embedding n, and then all these embeddings are stored in a vector database. Yeah, so you can see chunking, storing, and retrieval. So we saw the one part, external data gets chunked. It's divided into small pieces of content, chunks, and then each chunk is given a numerical value, what we call embeddings, and that gets stored in a vector database. So that is about storing. And what about retrieval? So when a user query comes in, even the user query gets converted into an embedding. It goes through this vector database to find the most nearest neighbor, what we call right, through semantic search and dot product. There are different techniques like Euclidean search. So that's how you get the response at the end. Similarly, if you go to any e-commerce store, Amazon, all the stores, uh, if you want to find the object that, I mean, like anything for example, this particular shoe you want to find, the shoe gets converted into a query vector. It goes through the vector database like SingleStore and does a vector search and to find the similar representation of the query vector, which is very most similar, and it retrieves back the most nearest neighbor, which looks similar to your query vector. Right. So let's talk about embeddings. Right. Embeddings in NLP, natural language processing, are powerful method to represent text in a form of, can be text sentence in a form of computer, where computer can easily understand that language. Right. So like we said, the documents get chunked, and each chunk is given with a numerical value, right? So this numerical representation captures basically in semantic meaning, relationships, and nuances of language, enabling your machine learning models to perform complex tasks like what we see, like sentiment analysis, machine translation, and all these things. So you can see in the image, king, queen, and man, woman. These are grouped together because they're more similar, right? Again, vector embeddings are a way to convert data into numbers that capture the meaning and semantic meaning in the relationships. For example, here there are words like king, man, woman, apple, banana, orange, football, golf, and tennis. You see, you need a embedding model in between. So there are different embedding models from, like, you can use OpenAI's embedding model, Cohere, Hugging Face, all these embedding models, and then all these words get converted into chunks, and these are given with a numerical value. And in a vector database, in a three-dimensional space, that's how they are represented, right? The king, man, woman are represented together. They're more similar. Apple, banana, orange, which are come under fruit, they are grouped together. Similarly, football, golf, tennis, sports, they are also grouped together. So this is how a vector representation again works. Like similar words are grouped together. Again, a vector representation of, I'm taking example of cat and dog, unstructured data. These are images. You need an embedding model which get converted into vector embeddings, and this can be represented. Uh, these are stored in a vector database. And what if you want to find the distance between two vectors? Like I said, there are different techniques like Manhattan distance, cosine distance, dot product, Euclidean distance. So again, Manhattan distance is calculated like this from point A to point B in a stepwise manner. Euclidean distance is more of a straight line from point A to point B. Cosine distance is calculated, the degree between the two vectors, and dot product is calculated like the perpendicular distance between the two vectors. So yeah, types of vector embeddings. We have word embeddings where words are converted into embeddings, and popular models include word to vec, glow, and fast text. Sentences and document embeddings. These capture the semantic meaning of sentences and the documents. BERT and Dr. Vec again are the examples here. Graph embeddings. These are used to represent nodes and edges of graph in vector space, basically. And uh, finally, image embeddings. These represent images in a compact vector form, basically, right? Um, and the types of what are the types of objects that can be embedded? So anything from audio, video, image, text, graphs, 3D models, and molecules. You just need to have an embedding model. Like I said, you can use from OpenAI, Cohere, and Hugging Face's embedding models. So yeah, these are some of the use cases of embeddings where all you can use them for. Why? Right, semantic search, right, text classification, and text clustering, and recommendation systems. You might see in Netflix, right? If you have watched something, the same genre of movies or series, it will recommend. So that's where we call recommendation systems, even in search engines, for semantic search and all that use cases. Those are some of the use cases of embeddings. Again, text as a vector embeddings. This is what I'm going to show you today, right? Text through an embedding model from OpenAI, it's getting converted into a vector embedding. So again, with a simple example, Pawan is a developer evangelist at SingleStore. The whole sentence gets chunked, and each chunk is given with a numerical value. All these things are embeddings are stored in a vector database. And if we go a little further, again, the same thing, external data gets split into chunks of words. And this process is called tokenization. And each chunk of word is assigned with a numerical number. That's what we call vector embeddings. And these are stored in a specialized database, what we call a vector database. Right. So a text, you need an embedding model, and that gets converted into embeddings. And there are different tools and techniques, tools to you can use as an embedding model, Cohere, OpenAI, and Hugging Face. So yeah, SingleStore as a vector database, right? So like we saw before, right? The external data gets chunked, and it is given with a numerical number, numerical value, and it can be stored in a database like vector database. So I'd like to tell that SingleStore had a vector storage capability back in 2017 itself. Since with all the hype of AI, ML recently, so now people are talking more about vector databases. But SingleStore is not just a vector database. Most of the companies use this for real-time analytics. Now you see, combine the power of real-time analytics and vector database, that coming together, SingleStore has much to offer for your AI ML applications. So let's get to the demo. For this demo, first thing is you need to sign up to SingleStore. uh, I'll take you through that step by step. uh, SingleStore, once you sign up to SingleStore, you need to go to singlestore.com. Hope you guys can see my screen. If it's your first time, try for free and then sign up. The first time you sign up, you'll get $600 credits. Don't lose that. So I already have my account. I'm already signed in. And after creating your account, the first thing you need to do is create a cluster, right? How to create a cluster? It's very easy. Let me go to my, right. So go to here. Well, first when you sign up, there's a step-by-step process. So you don't need to worry. This is how you can create a workspace. It's very easy. Select cloud provider as AWS, starter workspace, and then create a workspace. I already have my workspace created. I'll show you my workspace just in a second. Yeah. Happy workspace is my workspace, and under that workspace I have different databases. Also, you can also create a database. Next thing is to create a database. It's very easy. Again, select your workspace that you created, give a name like vector db or something, and then create a database. I already have my database named vector db here. So let's go here. Next thing to do is create a table inside the database to store our vector embeddings. So how you can do that is go to here on your left side in the dashboard here, go to develop and open SQL editor. Let me clean this up. Select your workspace. My workspace is this that just we created. And again, select your database under that workspace we create and copy this. This is the way you create a table under your database, right? Inside your database. Once you do that, just hit run button. The table gets created. The table name is vector table. And then now the thing is, we should create vector embeddings, okay, to store vector embeddings so that we can store vector embeddings in our database that we created under the table named vector table, right? So for that, let's go to, again, develop. For this, we will use notebooks feature, right? So notebooks is just like a Jupyter notebook that you use. Create a new notebook. Uh, I already have, I have already created my notebook. So this is the link to my notebook. Let it open. It's gonna take a minute. Guys, bear with me. I think it's gonna take a minute or so. I think it's loading. Yeah. Yeah, so here you go. So creating vector embeddings. Open your notebook and then we need, I'm showing you guys how to create vector embeddings using different like OpenAI, Cohere and through Hugging Face. So first using OpenAI, pip install OpenAI and pip install request. These are the packages you need. After that, import the libraries, mention your OpenAI key, and this is the format to create text embeddings for your using OpenAI. So that's how you create. This is the text. Pawan is a developer evangelist. For this particular sentence, this is the vector embeddings got created, right? So, and then creating vector embeddings using Cohere. So pip install Cohere again. Next thing is, this is mention your Cohere API key and the format to generate embeddings. So Pawan is a developer evangelist. Again, this is the text for this particular text I'm creating vector embeddings. So this is how the embeddings got created. And I use different text again. So that's one example, creating embeddings using Hugging Face. So pip install transformers torch, and then this is the format to create vector embeddings. Pawan, the text is Pawan is a developer evangelist again. So this is the embedding that got created. Okay, and John is a developer. So this is the example. You can change the text and so that you can see different embeddings getting created using different techniques. Like I used OpenAI, Hugging Face, and then Cohere. So yeah, that's how you create. Next, let's insert. Let's add vector embeddings created into the table. Let's create embeddings for our own text, right? So let me open this. We'll be using Cohere here to create our vector embeddings. And then, yeah, so let it set up. So yeah, let me run this. Right. So use this particular thing. I'll use some other text. Smith likes to play cricket. So if you hit it, that's how the embeddings get created. Let's add this thing into our SingleStore database, right? That we'll use this particular SQL query. We'll go back to our SQL editor. We have selected our workspace and the database. We have created a table. So inside that table, we're gonna add these. So now we need to change this hello world. It's not hello world. It's basically created. Smith likes to play cricket. And then in the JSON array pack, we will add the embeddings that got created. Right? So if I run this, I can go to my database. This is my workspace. Under that, I have the database created vector DB. And under that, I have created the table vector table. And let's see the sample data. Smith likes, you see here at the end, Smith likes to play cricket. So like this, I have converted most of the text already into vector embeddings. So you can see this is how the creation of vector embeddings happens using different embedding models. I used Cohere here. So next, let's perform a search, right? So again, let's use this query, the dot product query, and let's go to develop. We'll clean this up. Then we paste it. And then first we need to convert our query into vector embeddings, right? So for that, let's again follow the same thing. Copy this. Uh, we'll just say our query vector can be cricket or likes, or it can also be play. I don't know. Can create this, right? for our query, we created vector embeddings. Then let's copy these. So if I go back here and in the JSON array pack, if I if I do run, right, you can see, right, the what we used basically play, right? We used the text play for that particular thing. This is the score we got, right? For we added all the text. We converted most of the text, and we also did a semantic search, the dot product, and we can also see the score here for how for the query vector play. Right, so that's how you can use a single store as one place for all your LLM applications to as a single database to store your vector embeddings and do all that. So yeah, that's it from me. I have already I have written a lot about vector embeddings. This is one vector embeddings explained for developers, which got pretty good traffic and claps. Here I have mentioned everything step by step. You can go and follow this also. I think Matt will share this in the comments in the chat. And also this is one yesterday, I mean today I published it. This also has more content on what are vector embeddings, how to store vector embeddings efficiently, and then retrieve them using semantic search and all these things. Thanks, Matt.
Awesome. Thanks, Pavan. Yeah, there's been a lot of questions for those tutorials, so I just posted them into the chat. And there's also been dozens of questions coming through. So I know Akmal has been furiously typing, but we can try to get some of these live as well. And so here's one I see from Probit. So is the data inside vectors, can that be accessed through normal SQL as well? Not sure if I understand that. Do you understand that one, Pavan or Akmal?
I
okay, so I think what the question is being asked is, let's say we've got the vectors actually stored in the database system. Can you access them by standard SQL, for example? That's my take on it. Yes, you can. You could do. I don't know what you could do with the data. It's just arrays, right? It's the numbers. The benefit comes from it, as Pavan was showing, through the use of using these kind of similarity functions, dot product, Euclidean distance. That's what you're trying to do. Because remember, what is the vector? It's just a representation of some data. And with that representation, you now have it in a form that the machine can understand in terms of doing these kind of intelligent comparisons. Okay, that's the main thing. The database is just for storage. You can query it. You can look for specific values if you want, no problem. But what would you do with those values yourself? Okay, I'm not sure. Maybe there's a requirement for it. Perhaps the questioner had something in mind. If so, please just follow up and ask. Well, that's my understanding. So.
I think that makes sense. Here's another one, Akmal, and I know you've done lots of embeddings, and Pavan, maybe you have too, but Lovish says, explain to me how to choose the best embeddings, and is there a difference between, I think generally the overall question is there a difference in using an embedding for one use case versus another, or in what tasks? What do you think?
Pavan, do you want to have a go, or do you want me to?
I think best embeddings, you mean, I think he's asking about embedding model, which embedding model I should use, because if you use from OpenAI, it is like they charge. So there's a charge for that, but you can also use something like Cohere, like I showed, maybe from Hugging Face. Yeah, that's what I recommend.
I think the good thing is that if you look out, and just earlier today, I was looking on LinkedIn, And I came across a whole bunch of articles that people are posting there. For example, there's a gentleman, I think he works for Moonpig, and he's been doing a comparison of various LLMs, for example, and posting about them. So look for these comparisons, the kind of tasks that you want to run against, and what is the performance and the quality that you are getting back in terms of the answers. Sometimes you have to evaluate these yourself. I mean, there's no two ways about it. Okay, it's the old saying about, if you want a job done, do it yourself, right? Because someone else's use case may be very different from yours. And to the point about different LLMs and sometimes perhaps focusing on one particular area versus another, absolutely. I mean, if you think about it, I came across the example, it was Bloomberg, I think. They built something specific to their use case in their environment. Now, if you think about it, the kind of data that they deal with might be very different from what we deal with, for example, or somebody else, say in the retail industry. So there are these models built around specific use cases, and then you have to find something that's relevant to you. And again, of course, that sometimes the quality may not be as good. You just have to evaluate them, look for these comparisons as well, and then test it yourself ultimately to make sure that you're using the one that's the best fit for your problem. Just my general take there.
That makes sense. Yeah, it reminds me of, I love ChatGPT, and I'll often upload files to it and ask, talk to it. But it often has problems, like depending on how that document is laid out or arranged, like it's almost like the computer can't figure out, that design or that layout, like whereas a human can see it and just graph like, oh, that's one section, that's a different section, these are related. But supposedly, Alex has been telling me that Claude 3 is very good at that. So he's been working on that demo. I can't wait to see what he shows next week at the Claude 3 one. So we'll see. I see this one on how do you set chunk size and chunk overlap. Do either of you want to take that?
Yeah, so chunk size is very important, but that is again debatable depending on what you want to achieve, because this smaller chunk sizes offer finer granularity by capturing more detailed information within the text, and also larger chunk sizes provide a broader context. So again, it depends on what you want to achieve through your LLM application. So this is basically a debatable thing. Some people use a smaller chunk, some people use broader chunks, but now I see most of them talking about why you need smaller chunks generally.
Yeah.
That's my take. Yeah.
Good stuff. I like it. Let's see. Akmal, I know there's like a dozen questions in there. Do you see any that stand out to you that you'd love to answer?
Yeah, there's a question there from Basco, who's asking about how does the similarity search work for not equal search? Say I like hiking, we'll fetch hiking related stuff. What if we say I don't like hiking? Okay, so that's part of this semantic search. I mean, that's something that you could, if you're doing a particular pattern match, for example, let's say you're using dot product or Euclidean distance, they will return results in a particular order. You can cosine similarity is something that you can program within our environment and utilize that. But remember, these are kind of mathematical operations as well. So you can always say, okay, if it leans towards one side more, 1 minus that answer will give you the opposite, if you like. It's almost the kind of, you have to think about the negation, if you like. But remember that you could ask it, I don't like hiking. That will certainly be possible. You're not in a sense that what you're asking in terms of the prompt, that's converted into embeddings, and then it will try to match that according to the sentence that you put in, right? So this is, I think, what the beauty of this is. And don't forget, within SingleStore, we also have full text search. So there may be cases, for example, where semantic search is not appropriate. Simply you're looking on keywords or something like that, for which just use the Lucene full text engine. That might be better.
Good stuff. I see a question here from Hitesh that is there any way to calculate embeddings for an entire video? And I know Akmal, you've got your upcoming webinar. We can plug it here. I don't know if we have an RSVP page for it yet, but Akmal is working on embedding videos via notebook. So I don't know. Do you have the answer to that yet, Akmal, or still
Yes,
working?
so I'll give you the quick answer. Okay, so as Matt was saying, we have a webinar in the pipeline, and that will hopefully go up soon on our website. So essentially, the way that you can do it is, and the technique that I used is I used something called Clip from OpenAI. So I took a video and then I used the software to break that down into 1 second frames. Because if you think about it, we can't store the video. I mean, we can store the video as a blob, if you like, within the database system, but it doesn't have much meaning. So we need to get some meaning out of that. And one solution, okay, I mean, there are others, okay, but the way that I approached it was to say, okay, let me take this 2-minute, 22-second video, which is actually one of our munchable videos on YouTube, Matt. I think it's short enough to demonstrate this. And so I just broke it down into 1 second frames. And then for each frame that I had, I generated the embeddings. I stored them in SingleStore, and then I can query that and ask it interesting questions. And by the way, I may open it up when we do the webinar to the attendees to pose questions that we can ask on the video. And that's one solution, one way we could do it. Like I said, probably lots of other ways to do it. But yeah, we can do that. I think the only challenge there is if you've got something really long, several hours worth of video, then it may not be practical to do it this way. You might want to say, store a frame every sort of, I don't know, couple of minutes, every minute, say, rather than every second, something like that. Depends on how much quality you want out of that.
Good stuff. I just posted, we don't have an RSVP page yet for it, but it will be on April 11th. Stay tuned. Follow along with us on social media and our email newsletter, and you'll be able to register for that maybe in the next week or so. I see this one from Nushin. It says for local implementation of a RAG, what are some of the different vectorized databases you would recommend to ensure data privacy? Now, I know we just did a webinar earlier this week on tokenizing data and implementing role-based access control in LLM and Gen AI apps. So I'm going to post that link so that you can check that out if you want a deeper dive. But I don't know if Akmal or Pavan, do either of you want to talk a little bit about data privacy and AI apps?
Pavan, I'll give it a go, okay? And then if you want to jump in, please do so.
Yeah, sure. I mean,
okay,
yeah.
So we often get asked this question about protecting user data, and also, for example, if you're using these third-party vendors outside of your organization, you don't have much control over them. You as Pavan was saying, typically for, say, OpenAI, you have to pay them money, okay? You are using their service. You are sending them data. They generate the embeddings and send them back to you. So you have to think carefully. In the case of OpenAI, for example, they have a policy that they do not retain your data by default. I believe that is still true. I read that a while back. And so unless you give them specific permission to retain data, they won't do that. Now, there's other issues there in terms of you're sending data across the wire, across the internet, to a third-party website as well, in terms of protection for that data as well. So as Matt was saying, we did have somebody talking about this just, was it yesterday, I think, even, Matt? Was it? Yeah, we're on Thursday. So that, I think, was yesterday. So that link, I think, could be very useful. And then for an enterprise product like SingleStore, for example, as Matt mentioned, role-based access control gives you fine granularity in terms of protecting data, who can see it, how much they can see, and that's another great way to ensure sort of privacy. Ultimately, though, you may need to incorporate other methods, other means in terms of providing some level of data encryption as well, if you are really concerned about kind of unwanted eyes seeing things that you don't want them to see. that's something that you'll have to think about and add on. But for some, an enterprise product like SingleStore already provides a lot of capabilities in terms of control of data, access of data, and so on. And then just think about the LLM itself. If you have local installation of an LLM within your organization, obviously you have full control over that. And you can put in place the necessary systems and practices that will prevent unauthorized people as well. It's a challenge, I would say, yes. Within Amazon, for example, you could set up a private cloud. Yeah, that's something that would give you a lot of control as well. So there's things that you can try.
Good stuff. Pavan, do you see any questions? I know we've got a bunch of unanswered ones. Do you see any you want to address?
Yeah, somebody was talking about context window. What is context window in LLMs? So what I see that context window in LLMs is basically the number of tokens that a model takes as an input to generate response. And I also see an example like Chat GPT-3 has context window of just 2,000 tokens, while GPT-4 has 32,000 tokens. So yeah, that's the main difference, right? And I also see that somebody asking any on-prem solutions for SingleStore. Yes, maybe Akmal can.
Oh, I think that's part of our Helios Cloud offering, isn't it, Matt? Pavan?
Yep.
We've got something
Yep.
in the pipeline that will actually provide access to LLMs directly through our platform. I think that's in the works. I have no idea in terms of time frame. I don't know if either of you guys know about that. It's a shame we don't have someone from product management here, someone like Eric Hansen or one of our other colleagues that could give us a bit more in terms of the timelines. But I know it's in the planning and something we are actively looking at just to make it easier for our customers and developers to use.
Yeah, I'm going to send our pricing page as well, where I think it gives you the options to see that are already available. You were asking about on-premise. First of all, we're available on all the major clouds, but we also do have on-premise option, and we've got Kubernetes. So click around that page, take a look, and let us know if you have any other questions. Akmal, there's a good one here for you. I love the question. I know you're the expert, the resident expert on it. Is it possible to vectorize streaming data? I know you do a ton on Kafka.
Oh, yes, absolutely. And this kind of ties into what we were just talking a few minutes ago about videos. So I came across a wonderful article actually written by a gentleman on Medium. I think it was actually January last year he published it. He showed how to use Spark streaming to handle videos. To, in this case, essentially take a video and be able to stream that data. And if you think about it, you could extend that to, say, a stream that's coming in. Rather than the video and you're creating a stream from the video, why not take a live stream that's coming from outside and be able to handle that? And something like Spark Streaming, for example, could manage that. And so again, you need to think about what can you do with the data? How would you break it down? So I think that the solution that this gentleman wrote about was he was taking, again, splitting the stream into frames and not taking every single frame, but every few, and then storing that in a data warehouse and then generating embeddings from that using a library. And I was thinking to myself, and I may actually do this in the webinar that we have, I might actually go that extra step and demonstrate this using SingleStore with Spark, and then try and see if I can find a live stream somewhere that will do that. It might be a challenge, but it definitely will work with videos. But finding an external source of live data that's coming in and using Spark to manage that, I think that would be a great challenge. I'll see if I can do it.
It's interesting. It reminds me of, I don't know if you were on our Promptly webinar, but they've kind of built this agent that can navigate your browser. It can use your keyboard in your browser, and it just takes basically screenshots of where you're at on the internet, and then it says like, oh, this is a button, this is a whatever, and then it's basically taking screenshots and vectorizing that and guessing where you need to go next, where you need to click next. But there was some to figure out the right balance of too many. I think they were balancing like the sending too much to the API and like getting failures, and so they had to adjust that limit in some way. So kind of an interesting time, but maybe there's some like trial and error to get the best, get the best quality, but not too much or something.
Yes.
So very cool. Pavan, do you see any others? I know we still got a bunch open. Do you see any others that you like in the
No,
queue?
I'm going to them.
Oh, good. Oh, here's one that I kind of like, and I can't remember if we did a webinar on this. Can we optimize the context window by passing in vector embeddings of chat history? And so I know, Akmal, we've talked internally about doing like live rag or maybe like using the job scheduler. I don't know if you've used our job scheduler at all to try to continuously update that rag. Have you done anything in that regard, Akmal, or you feel like you can
I
answer that
haven't,
question?
but now you mentioned it, Matt, I think it's one of the notebooks that's in our gallery, in fact. I think there's something associated with that.
I think
And
you're right. Let me find that.
yeah,
Go
have a
ahead.
look at that. The job scheduler is kind of like a cron job. So for those of you who are interested, so Pavan was talking about the notebooks in our environment. So we have this ability now that if you don't want to run something interactively, let's say you've got a particular job that needs to be done, you can schedule the notebook itself to run at particular times and return some results. And so you could have it running continuously, for example, and like a stream of data coming in and evaluating that and writing it somewhere into SingleStore, for example. That might be a possibility.
Yeah, good stuff. I'm gonna need to find this later. In the meantime, I'm gonna post the gallery to folks because we just got so many great notebooks now.
Yeah.
And I'll also go ahead, Pavan. Were you gonna say something?
No, I was talking about the notebooks that we have. People can try them.
Matt, we did sorry, Pavan. Didn't we do a webinar not so long ago on this scheduling?
I thought we did, and I'm trying to think. I mean, we do
have.
like 90 per quarter now. Go ahead.
We had one not so long ago. It's the one that I was unable to do. We had some other colleagues from SingleStore doing that one, and they actually demoed it. We can send the link for that as part of the follow-up email as well. So we'll find that and send that, because I think that'd be great for people. If people are really interested in how they could do this, running this job in the background, having the notebook continuously updating, that could be a good solution for many people.
Agreed. I feel like I see some questions about chaining, and I'm trying to remember, was it one of you that did the intro to LangChain, or any stuff with LangChain that you could maybe talk about at a high level and maybe try to hit a couple of these questions all at once?
Yes, so this is what I mean, if you think about it, the LangChain, the chain bit kind of gives you a big clue as to how this works. So we've demoed the SQL agent and that quite a lot. I've used that one. Pavan, I don't know if you've looked at the others, but essentially you've got lots of, I mean, think of it a bit like in Linux, for example. You have a command that you run, and then the output of that command can form the input to the next one. And then you can set this kind of workflow of these commands taking output from the previous step and so on. And then right at the end, you get the ultimate kind of answer. So there's a level of filtering and processing going on as it's working its way through the workflow. And that's essentially what chaining allows you to do. I mean, it gives you the ability to process the data, filter it, clean it up, do other processing, and then send it on to the next step. And divide, it's kind of like the divide and conquer. So, each step has a specific role to perform, which is good because it's a bit like, and forgive the analogy, I mean, like the Lego bricks, okay? These things join together and they all have a standard interface and they all can be used to construct something. And that's essentially what it is. Good practices on that. I would highly recommend having a look at the LangChain website and community. There's an awful lot of discussion that goes on there, people sharing their ideas and best practices. I mean, it's yes, it's useful to us in SingleStore, but we don't focus on it per se, simply because it's an external technology for us.
Good stuff. I know we still have maybe a few minutes left, but we should save some time though for the raffle winner announcement and some wrap up. But Pavan, do you see any questions in the list that you'd love to answer while we're still here?
Yeah, I see one chunking data. How do I guarantee that the context is preserved? So that's where the chunking strategies come into the picture, like how the big chunks or the small chunks, and there are different strategies. And he's also asking, like, let's say I want to compare two documents and I chunk each of them. Do I get about comparing them, making sure that not losing on context? No, you won't lose the context, because that's the way to basically, chunk and vectorize. And then, because there is a vector embedding model which chunks the data and gives it a numerical representation, that's what we call vector embeddings, and store them in a vector database. So you won't lose any context, but you should be sure about what type of chunking strategy you want to use.
Good stuff. There's one more that's very interesting to me, and I think we'll have an even better answer in a few weeks. So the question is from Vishnu, and it says, when people are talking about context windows that LLMs offer, what does that mean? Does chunking matter in this situation? And I know, so the webinar that we're doing in a few weeks is called "Is RAG Dead?" Hands-on with Google Gemini's new 1 million token context window. And so I think the context is basically like, if I can send that much context to Google in one go, then why would I even need a RAG database? And I think and LangChain has since come out and said, no, you still need RAG for this, that, and the other reason. And I want to do something with LangChain on this. I think my understanding, my very, very limited non-technical understanding, is maybe this has to do with, especially in B2B use cases, you've got data over here, data over there, you got multiple databases, you've got images over here, you've got structured data, unstructured data in all these places. And so you still need to be able to, have access to all of those means. And so I think maybe do you have have you read anything about this, Akmal or Pavan, that gives any insight on that question or topic?
I haven't read that specific example you cited, Matt, but it sounds very interesting. But I think I agree with LangChain, because think about it. Yes, million is great. No doubt some people will find it useful, but for a lot of other use cases, it's overkill. Right, and it may not be the right thing to do. So, again, it's a case of pick the right tool for the right job.
Yeah.
And talking of which, there's a great question there from Casey asking about CSV, and how he finds that it just creates a vector for the whole file and not the row. The way to do this, Casey, would be just process one row at a time. Okay, so either take a row of the CSV file, iterate through it, and so as you're doing that, generate a vector for that, if you like, or you could actually store it in SingleStore first and then generate the vectors from that, and then doing a call out to OpenAI or Cohere or whatever is your favorite LLM. That's the way to do it. Divide and conquer, break the task down into smaller parts.
Good stuff. The other thing that you just reminded me of, Akmal, is just like that, the million context window. Alex Pang told me that one of his professors at Stanford Computer Science said, the way he described it was, if I'm a professor and I'm giving you a lecture, if I just give you a fact and then ask for it back, you're going to get it every time. But if I give you 2 hours of rambling and then I quiz you at random on stuff that was in that huge lecture, you're not going to really get it. He's like, it's basically the same with computers. You can just dump information at them and you could suffer some quality issues or recall, or not have the right context or whatever. So it does seem like there is some, it's not as easy as more context, problem solved. Anyways, things to consider. I think I'm going to wrap up and announce that raffle winner, unless either of you see like a burning question you want to answer before I do that.
No, Matt.
Go.
How
Go
many
ahead.
how many minutes we have still?
We still have 6 minutes, and so you maybe have two
Can I
minutes if you want to answer.
share
Go,
something? Yeah, I
please
want to
go.
share
Go.
something. Yeah, let me share. I just want to share and let people know that what I showed was a step by step of word sentences, converting them into vector embeddings. You can also take a a complete CSV file or a PDF and convert that into a vector embedding. Convert that into vector embeddings, and then store them in a vector database like our SingleStore. So, and then you can do similarity search, right? Semantic search. So yeah, that's what I wanted to tell. So what I showed was a step-by-step thing. uh, what if you have a large document? You can convert the whole thing, chunk it, and then convert that into vector embeddings.
That's awesome. Really cool. Pavan, could you share the last slide of your deck while I do the raffle winner?
Yeah,
So
yeah,
one thing that I wanted to notice, I'm just going to copy and paste it into the chat as well. If you like today's topic, there's another related topic that we're doing next week. Like I said, we do multiple webinars per week, but next week we're going to be doing Beginner's Guide to Vector Databases. We're going to have like a classroom style whiteboard. We've invited Professor Tom Yeh, who is a CS professor at CU Boulder, University of Colorado Boulder. He's going to do a whiteboard session. It's really cool. Come, join us and learn more about the fundamentals of vector data and why they are so important in these AI applications. There's the link in the chat. Hopefully you'll RSVP and I'll see you next week. The announcement you've been waiting for, today's raffle winner is Ragesh Rajan, Director of AI at Ally Financial in California. Congrats, Ragesh. Thanks for joining us. If that's not you, don't fret. We're going to give out one more raffle prize winner to someone who has tried out Pavan's demo today. Like I said, I put those two blog posts in the chat. We're going to include that as well as some other resources. All you need to do is sign up. We'll track those signups today or log in if you've got an existing account. We'll give out one more, either AirPods or Ray-Bans, Meta Ray-Bans today. So give it a try. Thanks so much, Pavan and Akmal. Awesome session as usual. Have a great rest of your day.
yeah. Thanks.
Bye, everyone.
Bye.